Hello, everyone. Welcome to this new live stream webinar brought to you by CrateDB and Concept Reply US. Welcome. This webinar is being broadcast to LinkedIn and YouTube. So welcome to everyone. And I'm very excited today to welcome Stefan Becker, Senior Consultant at Concept Reply. For the ones who watch the Horse Whisperer, so it's not Robert Redford, but it's even better. And he will simply ask the AI-powered manufacturing assistant a few interesting questions and walk you through a very interesting demo. Welcome, Stefan. How are you today?
I'm doing well, Stefan. Thank you so much for having me on this webinar.
Yeah, so you have some interesting thing to share with us today. So I will let you maybe introduce yourself a little bit briefly, and also Concept Reply and the use case you want to go through with us today.
Perfect. Right, so I'm Stefan Becker. I've been an AWS solution architect for 8 years now. As of late, the last few years, I've been focusing on end-to-end IoT solutions on the cloud. Today in this demo, we're going to be focusing a little bit on using GenAI and LLMs in the factory to understand the overall equipment effectiveness of your systems.
That's great. So can you introduce us a bit Concept Reply and your different activities?
Yeah, of course. So, Concept Reply, as I mentioned, we do end-to-end IoT solutions. So we look at going from the strategy definition to, what the business drivers are so that we can implement that across the entire value chain. And so our current focus is in the automotive and manufacturing sectors, bringing sort of smart infrastructure into the factory. Our key expertise is in technology integration, right? So how can we augment what you're doing currently with hardware and generating insights with that hardware and IoT technologies to drive better business outcomes? So outside of the factory and manufacturing, we also do custom development. So from, let's say, web applications to iOS development. And then we also have sort of our cloud and IoT advisory, which is sort of my focus area. So we can give you sort of comprehensive consulting solutions on your cloud and IoT strategy.
So very comprehensive. So today, so what you told me that what people will learn is using a voice assistant to speak naturally and to know what's going on in the factory. So we are targeting today, we are going to really focus on manufacturing, what's happening on the factory, and so how people can get predictive insights. Yeah, it's always a big question we get. More and more companies try to empower their teams on the factory floor with more and more tools, but these tools need to be easy to use. Most of the time, people have gloves. They are in complex conditions. There is noise. There are a lot of things going on, and there is also a sense of urgency if something goes wrong. So they need to react very quickly. So what you would like to showcase today is interact in a natural language with some machine and get some interesting questions answers to some questions. So what are the typical questions we are going to ask in your presentation?
Yeah, so you got to imagine, if you have a factory with a bunch of complex systems, the goal behind this project was to sort of aggregate all of the, let's say, shop manuals, time stream data from these machines, the different sort of metrics around what makes a factory run, so that you can ask things like simply, what is our current OEE? And if there are, let's say that value is not high enough or permissible, you can ask, what is affecting the OEE? If it identifies a specific machine, you can ask things like, what is wrong with conveyor 1? And it will reference the actual manuals for that machine to understand, okay, let's say the vibration of that machine is too high. The manual says the vibration factor for this machine is X. It'll tell you, hey, this machine is vibrating outside of spec. Maybe it's time for maintenance. Or what does the troubleshooting guide say? What does our manuals and our procedures say we can do to solve this problem? So different things like this. Obviously, no LLM is good without having some good guardrails, so it won't teach you how to cook pasta, unless that's maybe what your factory is doing, in which case, that's a little
Who
bit
knows?
different. Yeah. And so in the demo today, what we're going to show you is a stream or a video that I pre-recorded of me interacting with the LLM agent I created. We pre-recorded it because I noticed when I do webinars, there's always some kind of permissions issue with the microphone because it is, capturing the live stream of your mic. So, it just always causes technical issues to switch between the front end portal of the AI agent and the live stream. So we just wanted to eliminate some of those technical issues.
Excellent. So let's go through the demo, and after that, you will walk us through the architecture, and we can go a little bit deeper into what's underneath.
Perfect.
It's a truly multi-model AI solution, so operators can speak naturally using Nova Sonic to get insights about what's going on in the factory and get predictive analytics from Nova Pro. The powerhouse of the solution is CrateDB, which is an open source distributed database designed for real-time analytics on large data sets and varied data sets. So it can inject or ingest time series, structured, unstructured, blob data, all those kinds of things. And so to sort of get into the actual demo, let's start asking Nova some questions. What is our current OEE?
Our current overall OEE is 58.4%. There are some concerns with conveyor 1 and the press machine, both showing 0% OEE due to high vibration, overheating, low performance, and equipment downtime. Would you like me to dive deeper into any specific area?
What's wrong with conveyor 1?
Conveyor 1 has a vibration level of 11.207, which is significantly above the normal threshold of 1.5, indicating severe mechanical issues. The temperature is at 69.56 degrees Celsius, which is also above the optimal range of 45 to 60 degrees Celsius, and the RPM is at 974.47, which is below the expected operational range. These readings suggest serious problems that need immediate attention. Would you like me to provide troubleshooting steps?
Yeah, what does the manual say are the troubleshooting steps for this machine?
According to the manual, for conveyor 1, high vibration above 1.55 may indicate imbalance or bearing issues. The temperature above 72.5 suggests overheating and RPM deviations. Above plus minus 100 RPM require inspection. If the vibration exceeds 1.75 or the temperature exceeds 77.5, the emergency protocol is to 1. Immediately reduce the load. 2. Shut down the motor if the anomaly persists for more than 5 minutes. And 3. Notify the operations lead and schedule maintenance. Let's follow these steps to resolve the issues with conveyor 1.
What's the failure risk for assembly line A?
Assembly line A has an OEE of 97%, with availability at 100%, performance at 97%, and quality at 100%. The line is currently running without any reported issues. The failure risk appears to be low based on the current metrics. However, it's always good to keep an eye on it to ensure sustained performance. Would you like me to monitor it more closely or focus on another area?
No, tell me, how do I cook pasta?
I'm specialized in manufacturing and OEE analysis. Let's focus on your production needs. What would you like to know about the factory?
Yeah, what parameters can I check?
For the factory, you can check overall OEE, specific machine OEE, sensor readings for machines, and troubleshooting guides for any issues. Let me know which one you're interested in, and I can provide more details.
So yeah, as you can see, the model is very great at checking the current data of the machines and their parameters in the database. It can give you insights based on machine manuals that were loaded into CrateDB. And it even has guardrails, you know, who doesn't at this point, to make sure that an operator doesn't deviate from the questions that this model specializes in. It's just also a rudimentary dashboard that I came up with. You can see the overall OEE calculated in the background, and then you can see the machines that were having issues that we asked about. And like I said, you know, you have some predictive insights here that update every hour or so based off of data in the database. So this has been my demonstration of our OEE Whisperer. Thank you for watching.
That's a great demo. Thank you, Stefan. So let me put you back on. So this is very impressive. I think this is what we're going to have in the future in many areas and what we're going to call modern apps, you know. So very cool. So you want to walk us through a bit into the architecture. Well, how is it working underneath, you know, behind this magic?
Yeah, and so the heart of the system is obviously the data that you feed into CrateDB, right? So in the demo, you know, let's say like it was saying, you know, there's 0 OEE, but the machine was running, and it was saying it was vibrating at 75 when the machine was the parameters were 1.75. So I mean that was more just up to the demo data that I gave it. And it really sort of speaks to how well these things run when you give it good versus bad data. So it all starts in the shop floor of so connecting to CrateDB. So you send in your SCADA data, machine manuals, sensor data. You can send them in JSON format. You can connect with, or you can do it in sort of like more structured SQL writes. CrateDB accepts time series data, blob data, or even geospatial data. This connector here, which is the little arrow between the shop floor and CrateDB, represents the connection between the two. So you can do this with, let's say, a JDBC driver to connect to it like it's a normal database, but you can also do REST API calls over HTTP directly into the database. From CrateDB Cloud, I had a Fargate container running that hosted the front end, so the actual say dashboard that you saw, which connected to AWS Novasonic via API using a WebSocket connector. Novasonic, I honestly didn't do much to configure it. I just created credentials to secure the endpoint. That's just, you know, AWS IAM credentials. And with the queries, you know, there was sort of a preamble prompt engineering of, you are a manufacturing assistant and you focus on these key areas. The conversation, drifts from machine or manufacturing specific questions, guide the conversation back. And also told that, these are the functions available to you to query the database. So based on the questions, you can use these different functions to get the insights that the operator is asking for. So the Novasonic part was actually pretty simple, let's say, setup. There wasn't really, you can go deeper into SageMaker on AWS and sort of pre-train a model, set up a RAG, all that kind of stuff. But I didn't do any of that. I just set up the API endpoint and told it, this is where the database is and this is the data you can access. The front end was behind reverse proxy. In this case, it was AWS's application load balancer, where you can, where I connected to it via just a web browser, right? The interesting part to me about Novasonic and the front end was, it captures the live stream of your microphone. So it's not doing anything like transcribing what you're saying, sending the transcript to the model, the model gives back a transcript, and then the front end turns that into voice. It was not doing any of that. It was directly taking your voice, feeding into the model, and the model was speaking back, which was actually an interesting problem to solve, because you saw sort of in that chat window, there was a transcription, and I had to create sort of a custom endpoint that would take the output of what the model was saying to actually be able to render that in the chat window, which is why there was repeat messages and stuff like that. Trying to think what else was interesting about this project. I don't know, Stefan, if you have any other questions, sort of.
No, thank you. I mean, this is definitely very powerful to leverage Bedrock and Novasonic, very powerful model. In terms of data, and that's something you mentioned earlier, yeah, you can ingest different types of data from different systems. If you are having your sensor data, you're naturally going to have time series data coming in at a very high rate. Then you can also import more relational data, like your machine data, metadata. You can also have JSON files that you can export, or you can get automatically from different systems. And also, you mentioned documents and things. There are more. They can then turn into text, and you can also ingest this text data into CrateDB. So I think that's a nice transition also to what CrateDB is. But before that, I will let you just say, okay, what are the things you discovered during this prototype and this demo, and what are the new ideas that came up to your mind when working on it?
Yeah, so you could say the mistake I made was using CrateDB as just another database. I mean, it is great at that, because you can store data in completely different structures, and it's very, let's say, flexible in that way. But to empower this, or to enhance this from an AI perspective, I could have added float vector columns and generated embeddings based on my shop manuals. So a float vector in CrateDB is a special data type that stores mathematical fingerprints of your content. So you can think of it like a barcode that captures the meaning of the text and the data patterns. And embeddings are also mathematical fingerprints that AI models create to represent meaning, in this case, specifically meaning of the maintenance manuals, the sensor readings and log files as numbers. So by adding these float vector columns to store these embeddings, I could have kept my regular data as timestamps and machine IDs, and then, let's say I could have kept them both alongside each other. So I could still keep the regular data, the timestamps, the machine IDs, and then the meaning patterns in the same database, making everything searchable together. So with those two data types stored together, you can use K&N matches in CrateDB for finding similar situations or similar data. K&N means K nearest neighbor match. It's a type of algorithm you can use, and it's a function in the database to help you find similar patterns in the data. So you can think of it as asking, show me the 5 most similar situations to what's happening now. So when you have a new sensor reading or a problem, K&N match searches through all your historical embeddings to find the closest match. This is the core technology behind spotting unusual patterns and understanding, what happened in similar situations before. The other thing I realized is I could have enabled sort of full text and hybrid search. Instead of, I did SQL queries, but I could just do full text searches using CrateDB's match operator, which works, like a traditional Google search or Elasticsearch. So you can find exact word matches. You can do sort of hybrid search combinations. You can also combine hybrid search with semantic search. So when you search for low vibration fault, you get both documents that contain those exact words, giving you more comprehensive results and more data for the model to interpret. And then getting into a little bit more in the weeds, I could have integrated LangChain and RAG pipelines which is like a popular framework for building AI applications. If you're not familiar with RAG, it's a retrieval augmented generation. It's a technique where AI chatbots first search through the specific data before answering questions. And in your RAG, CrateDB becomes your vector store, the database that holds all the embeddings for searching. So when someone asks a question, LangChain uses k-NAND match to find relevant information from your manuals and logs, and then feeds that context to the AI to generate informed answers based on your equipment and experience. So I don't know. I mean, there are many things I could have done to make it better, but I think what surprised me the most about this project was it still worked really well. And as you saw before, the architecture was very simple.
Oh, thank you, Stefan. Yeah, it was great, and it's a good transition also to what CrateDB can do, and I will cover also the RAG architecture in the next few slides. So just to explain a bit how CrateDB is structured and what is meant for. I mean, take it as a distributed database, with different nodes. You can scale from one node to hundreds of nodes, but of course, most of our projects are built with 3, 6, 10, 15 nodes maximum. I mean, unless you have really massive amount of data. But that's something that can scale very easily. You just need to add more nodes. So it's a horizontal scaling. And it's really meant to for real-time access to fast-moving data. And that's something, when you talk about fast-moving data, what is it? It can be IoT data coming from your sensors. You get massive volume coming from there. It can be also events coming from streaming platforms like Kafka, where you need to ingest in real time and know what's going on. It can be CDC, so change data capture from traditional databases like MongoDB, where actually you need to get powerful real-time analytics, and you need to leverage CrateDB to go very fast and get all these insights, but also combining other sources of data. And you can also import log files, for cybersecurity, fraud detections. And Stefan mentioned the capability of CrateDB of doing some search, and that's very powerful for this type of use case. So take it as this distributed database that is also using SQL. So the query language is SQL, which makes it very simple to use and very universal. And it can very easily scale horizontally, but also you can grow your nodes with vertical scaling, and regardless of the structure and the volume of your data. So in terms of capabilities, you can make very fast aggregations across different dimensions. You can make ad hoc queries. So ad hoc queries are queries that are not meant to be done, at the very beginning when you think of your analytics. But at some point you say, oh, I want to analyze what's going on here. Maybe I should make a specific query a little bit custom, making some different joins and filters and groups, and say, okay, I need to analyze what's going on. And most of the time it's very difficult to do if your a database is only meant for aggregations. And here you can also make these very complex joins and ad hoc queries. In terms of search, it combines different things. So similar to what was explained earlier, you can have full text search. You can have a vector search for semantic search. You can combine both, and you can also have geospatial search. And with AI, and that's something also we are going to cover in more details, you can have different patterns to integrate CrateDB into AI frameworks, whether it's traditional machine learning models or Gen AI frameworks, or also with agentic AI with orchestration. So in terms of key capabilities of CrateDB, I already mentioned the multiple data types. So whether it's structured data, unstructured data, or semi-structured data, everything can be stored into CrateDB. It's a single storage. You can do real-time ingestion of all this data, and it automatically indexes your data. And that's the power of CrateDB. The latency between ingestion and indexing and querying is a matter of a second maximum. So it's very, very fast. So you get instant insights into your data. And also something very useful for complex analytics and AI integration is that it's auto-indexing all the columns by default, whether they are tabular columns in your table, but also if you have JSON objects, you automatically index all the fields into your JSON objects, regardless of the depth of within the object. So that's very powerful. So you can easily join, for example, a field within a JSON object with a column in another table. and that's quite unique. Also, in terms of schema, if you imagine, for example, you get new sensors that are being introduced in your on the shop floor with new metadata or new types of data being sent. For example, if you get a new sensor generation that adds a new field, the schema can be considered as dynamic if you want, which means that you don't need to, the system doesn't need to break down, and you don't need to update your schema manually to keep working. It can dynamically adjust and make sure it takes into account the new columns being added. Well, of course, it can be more strict or it can be more flexible depending on what you want and depending also on the field or the table you're considering. In terms of architecture, it's cloud native, so it's based on Kubernetes and it's distributed. And also, so you have this shared nothing architecture where every node is considered as equal. Every node can take ingest, can take query, and if a node fails, there is a quorum being redefined, and you keep a high availability in your cluster, which gives a very high resiliency. And SQL is a natural language that we are implementing natively. And regardless you're considering aggregations, other queries, search, or AI vector embeddings, you can use SQL to make all those queries. So if we look a little bit deeper at the time series data, we have many different functions available that allow you to have all the power of some traditional modern time series databases. You can extract time, you can bucket time, you can make some window functions very naturally with SQL. You can also make some null handling, have some aggregates, statistical aggregates, make some advanced filtering and logic. And also you can leverage some native capabilities of CrateDB, which are sharding and partitioning, to really get some optimal usage of your data. For example, if you have tons of data coming in, you can partition by week, by month, by year, and you can store your different partitions on different types of storage, which makes it very cost efficient. So here are a few examples of queries you can make with CrateDB. So it's everybody will find it very familiar. It's SQL, but you can embed those different functions I just mentioned, and you can see also you can make commentable expressions, and it's not mentioned here, but you can also make user-defined functions. I mean, there are this type of capabilities available. And if you look at the one on the left, top left, it's a typical time series query where you are binning, you are considering a specific window, specific interval, and you want to know what is the average battery level at this on this interval, and then you combine these results with some other results like metadata to get a nice result that meets your dashboard needs. Below, you have a typical example of geospatial query. We support geospatial data, and we have some interesting way to query the data in geospatial, whether it's a distance, it's a shape. We can make some different filters on geospatial data. On the top right, you have more a query that reflects what you can do in terms of search. So you leverage the match predicate to do some interesting search. You can also fine-tune the way your search is working when configuring your table, and so it's very you can also use different tokens for your search. Below, you have something that is more related to JSON payload. So if you have JSON payload, you can easily with some brackets notation, you can easily query fields within the JSON object. And the beauty that you can also join, as you can see here, just at the bottom, you can join a field within your JSON object. You can join it with a column within a relational table. So that's there are a few examples of queries you can make with CrateDB to really cover those aggregations, ad hoc query search on different types of data. When it comes to AI, there are three scenarios I would like you to walk you through. The first one is a typical machine learning integration with CrateDB. So assuming you're leveraging Python, you might have some specific things like Alchemy or Pandas. But you can use CrateDB very easily with a Python driver. You can use CrateDB as a feature store to train your models. Once your model is stored, you can use CrateDB for real-time inference. And also when you're making your predictions, if you're making some predictions and so on, you can also store the results of your predictions of your models into CrateDB as well. So it can act through different phases of your machine learning, training, and inference. Then if you look at something that Stefan mentioned earlier, a RAG pipeline. So this is a typical flow for a RAG pipeline. So you can use CrateDB as a vector store. So you can have the beauty that you can store all your data, metadata, and so on. You can store the text itself, and then of a document, for example, and then you store the embedding. This way you can combine both vector search and similarity search on the vector embeddings, but you can also combine full text search. Both can provide some different types of scoring and matches, and from there you can make the best decision whether it's more exact search or approximate search, or if it's more a semantic search related to patterns. So the way it works is that we store, with an LLM, you create the embeddings, you store the embeddings into CrateDB, and then through a chatbot similar to the one we saw earlier, you can ask a question, it generates the embedding for your question, and then you make a similarity search on CrateDB to see the similar vectors. He retrieves the vectors, and from there, he sends these results into the LLM that generates the response automatically. So here you see a typical query to search for a specific, for an exact embedding, but also we have similarity search functions as well to find the nearest neighbors. And then we see more and more projects around agentic AI, and the way it works is more an orchestration thing, where actually you get different agents that are specialized in different areas, similar to the ones you see on the right. And these agents are having specific functions and missions, and they are interacting with CrateDB through an MCP server. So we implemented recently an MCP server on CrateDB so that any LLM can interact with CrateDB on specific functions and get the results in real time. And here as well, it's a matter of real time. Imagine, for example, a complex scenario that needs to orchestrate different actions. It's very important that you get the information in real time to make the best decisions. So we see more and more a bigger shift from batch pipeline to real-time pipeline in different projects. And this is where CrateDB excels, is very good at providing those real-time insights for your different agents. So that's pretty much it, Stefan. We walked through quite a few things here. I don't know if you want to add anything. Just maybe as if people want to learn a little bit more about CrateDB, that we have an academy, and you can get a nice certification. It's very self-paced training to get some fundamentals. If you want to know more about Concept Reply, is there any resources, Stefan, you would like to point people to?
Of course. Conceptreply.com is a very easy way to reach us on the web. And then always, feel free to reach out to me on LinkedIn if you have any questions. I'm very eager to help where I can.
Yeah, and so Concept Reply and CrateDB are partners. So we are working on some projects together. There is a center of competence at Concept Reply, and they are very keen on helping you out with your different AI projects. So it was a nice demo, Stefan. Thank you very much.
Thank you.
And we are getting to the end of this live stream webinar. It's also being available on our YouTube channel, on our LinkedIn channel as well. So feel free to watch the recording to share. And I would like to thank you very much for this presentation, for your time, and thank you everyone also for staying with us.
Thank you for joining us. See you guys.
See you. Bye-bye. Take care.